Welcome to ETM 260, Computer Aided Design. This is Lecture 3, Adding Geometric and Dimensional Constraints to the Sketches. This video is supplemented by the PowerPoint given for the class. The basic principle of using constraints in a sketch is to restrict its freedom to move or to change size in order to make it more stable. A sketch is said to be under constraint if the constraints are not properly defined. Fully constrained if all the needed constraints are well defined, and over constrained if additional or unnecessary constraints were defined or are redundant. In order to show you, let's open NX, and we're going to open File, Lecture 3 Part 1 in order to start showing how to add constraints. For us to open the sketch, we're simply going to the Part Navigator and double click on the sketch. Notice that this sketch requires 17 constraints to be fully constrained. We're going to start with dimensional constraints. The dimensional constraints are in the Home toolbar, and notice that we have multiple choices, either rapid dimensioning, linear, radial, angular, or perimeter. For rapid, NX will try to guess which one of the dimensions you would like to do between linear, radial, and angular. If you want a specific one, then choose that particular dimension. We're going to go for linear dimensioning. Notice when you are going to choose a object, you have the choices, since it's a line or 2 points or a distance, you choose 2 points. For example, choose the beginning point of that line and the ending point of this. Notice that NX gives you the choices of going between infer, if you want NX to guess what is the type of dimension that you want to add, or you could go for a specific one dependent of what information you have, whether it's horizontal, vertical, point to point, or perpendicular. In this point we want a vertical dimension, so we place it this way. Notice now we're gonna go for a vertical too. For this side, we could choose only the line, and notice that NX realizes that you want a vertical dimension of that line. Now we're gonna go horizontal for the bottom line, and then we're gonna do the same process for this line, and then a horizontal dimension. Notice that all the dimensions, linear dimensions, are provided, and they are constraints, and they are now in blue. We're going to now add radial dimensioning for the upper curve. We select the curve, and notice that it gives us a radius. And then we close. We're now going to learn about geometrical constraints. These constraints allow the users to relate sketch entities using standard properties such as collinearity, concentricity, tangency, and many more. This is a list that shows the icons and the name of the geometrical constraints available in NX. For the time being, avoid using fix, fully fix, and a point on the curve. Now let's see how to use these geometrical constraints in NX. We go back to the sketch that we were using before. To add geometrical constraints, we could go into more, and then notice that the icon is inside of here. I prefer having icons inside of on a particular toolbar, so I'm gonna add it. Simply go to the command finder, and then I'm gonna type geometric. It gives you all the possibilities of command finder. Notice that it says that it's currently hidden because it doesn't show in a particular toolbar directly. So what we're gonna do is we're gonna click on this arrow over here, add into the ribbon, and then I'm gonna add it directly into home. So now notice that I have an icon directly on my home tab. To add geometrical constraints, simply click on them, and let's see. To add geometrical constraints depends 100% on how do you want to fix the part. one of the things that we want to see is what type of motion the parts have, and to avoid having that motion. For example, notice that I have this line is able to drag from one point to the other. So two things. One, the location is not fixed, and two, notice that it's not connected to the other curves. So the first thing that we're going to do is we're going to connect them. For that, we're going to go to geometrical constraints, and we're going to use the coincident constraint. That means that I'm going to take 2 points, and they're going to align into one single position. I'm going to select the end of this line, and I'm going to constrain it with the end of this curve. So notice that in some cases he might give you choices. I want to make sure that is the start point, not the center, because we don't want to align it to the center. Notice that my menu directly gives me 2 choices because I have it automatic selection progression selected. And I go again, the end of this line with the end of this line, the end of this line with the end of this line, and the end of this line with the end of this line. Notice now that every single one of the endpoints of all the features have a blue point, which indicates that they are coincident. To test that everything is how you wanted it to be, notice that if you drag, the whole feature drags, and there is no missing points or misconnections in between the parts. So now notice what we want is we want to make sure that this doesn't move side to side. So we would like to constrain this to the origin. So this point, it is aligned with this origin. So we're going to use coincident now. We're going to do that the end of this line aligns with the origin. So notice what happened. Yes, the lines are fixed to the origin, but everything in terms of the shapes changed because they were not geometrically constrained. The sizes didn't, because the sizes were fixed previously. So let's just start by making this line completely vertical and this one horizontal. We click, and when we make horizontal, and we select this one to be horizontal, and then notice we want this one to be vertical. Then the last constraint that we would like to add is to ensure, notice that we have a curve between here and this part. We actually would like them to be tangent to each other. So we select tangent, and we do this and this. Notice that by adding that constraint, the feature becomes over constrained. So we're going to remove some of the dimensions in order to see if the over constrained part we have it's removed. So we're going to try removing this dimension, and notice that in this case it becomes fully constrained. How do we know that it's fully constrained? We see it over here at the bottom indicating that it's fully constrained, and also if you try to drag at any point, you will not see any change in the shape or in the geometry of your sketch. We're going to go through another sketch to show the process to make it fully constrained. To do that, we're going to close the sketch, and we're going to open part 1A for lecture 3. We're going to double click on the sketch. The process of constraining a sketch is a trial and error process. In many cases, depending on how the part is set up, it is better to dimensionally constrain it first and then do the geometrical constraint second, but it all depends. As you notice, in this case we have 56 constraints missing to be able to fully constrain this part. We're going to start with some geometrical constraints, and then I'm going to show you some of the techniques that I like to use to be able to go back and forth. So for the geometrical constraints, the first thing that you always have to double check is that all your curves and lines are coincident to each other before you do anything else. So in this case they are not, because we do not have blue points in between them. So that's the first thing that we're going to do. We're going to do carefully coincident between one and the other one, one and the other one, one and the other one. Oops, notice that I chose the wrong point. So the end of this line with the end of this curve, not the midpoint. So you just gotta be careful of what part you select. The end with the end, the end with the end. And notice that in this case I'm only missing, oops, notice that I selected the center instead of the end. That's why we just do undo, the end and the end. Now it's all the coincidences have been added. The next thing that we're going to do is to ensure that they have the same length in between the lines. So we're going to choose equal length. So we're gonna make this one equal to this one equal to this, and this one equal to this. Now that I know their equal length, I usually like to go back and provide a dimension to them so that that line or that size doesn't change. So notice that in this case I only have to dimension 1, and I'm going to do vertical. So I'm just gonna make it equal to 20, and notice that both of the lines will change to match that dimension. We're gonna do the same thing for this one, horizontal. We're gonna make them equal to 10, and notice that both of them will change. And we're gonna do this one, and we're gonna make it once again equal to 20. So now the size of those lines will not change. Notice that if you were to change one from 20, let's see, to 25, both of them will have to change. Oops, to 50 instead. So that is what we want exactly. If one changes, the other one has to change with it. We're gonna do the same process now for the radii, for them to be equal in size. So we're gonna do equal radius, and in this case we have 4 of them, so we remove the automatic selection process, and then we simply do this is equal to the 4th. Okay, notice that now what we see is that there is no tangent behavior between the lines, which is something that we needed. So we're gonna go around and add it. This line is tangent to this. So notice that because I didn't remove the automatics, we didn't add the automatic selection, it did the wrong selection. So we're gonna undo, click it, because we only needed 2. So this line and this line are tangent, and that is a big mistake. And that happens sometimes when you're doing constraints, and it's because simply sometimes the other parts are not fully constrained. You simply click undo or Control Z to go back, and we're gonna add tangent from another locations to see if the same behavior happens. I'm gonna do this is tangent to this, 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 and go around. Notice that as you go around, the line in front of the in top of the circle shows up, which indicates that it's going to be tangent. Notice that as we were doing the tangent, we started in another location and we went our way around, and it worked out. However, we noticed that some of the lines they lost their orientation. This one is supposed to be horizontal, and this one, so we're gonna make it horizontal. This is horizontal, 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 and we're gonna make this one vertical, 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 and vertical. Now the other thing that we want to make sure is that the circle, that these 2 circles have the same center. Therefore, we're gonna make them concentric to each other. We're gonna make this circle concentric with this. Okay, and we're going to make sure that this line has the same line as this one, meaning that they're gonna be collinear. So now we do collinear and collinear, and notice that they fall in the same line. So notice that we're getting closer. We're 5 constraints. And as I said, this process is a trial and error. There is not a specific right way of doing it or a wrong way of doing it. You just have to try different things. Notice that if we try to drag this, the sizes are going to still change because we haven't fixed many of them. So let's try to fix the size of the radii of the curvature in the top. And let's make it 65. And we're also going to do that for the diameter over here. And let's make that 25. So notice once again, if we try to drag it, notice that now the shape pretty much remains the same. What is not constrained is the location. So what we're going to do is we're going to constrain it. We're going to make this horizontal line collinear with the x-axis so that it's not able to go up and down anymore. So we're going to do collinear between this horizontal axis and this. Okay. And then the other thing that we would like to do is so that if we try to drag it, notice that if we drag it, it's still changing size, and it's because we haven't constrained the size of the radii for the four corners. So we're gonna constrain it, and let's make it into 10. So now notice that the only thing that is missing is that if we try to drag it, this is able to go side to side, which means that it needs to be fixed along the y-axis. So for that, what we're gonna do is we're gonna use the midpoint constraint. What that is going to do is gonna choose the midpoint of a line or a curve that you select, and we're gonna make it so that the midpoint aligns with the origin. For example, we're gonna select midpoint. So we're gonna select this line. You never select the actual midpoint, you select the line so that the next calculates the midpoint, and then I'm going to align that midpoint with the origin. So now notice that this sketch is fully constrained, and we were able to use pretty much all the constraints, geometrical constraints that are available in NX, and we also added different type of dimensional constraints, linear, horizontal, vertical, horizontal, and some radial ones. In many cases, it is necessary for you to get quick values of distance, radius, or angles without having to go to the sketch. A good way to do that in NX is to go to the analysis toolbar and go to measure. Notice that we have multiple choices, and then as soon as you click on a line, for example, it will tell you what is the length, what is the starting point, the end point. Let's say you want to find out the relationship between two lines, in this case the angle. You will click the second line, and it will give you the angle in between. If you want to, for example, find out the radius, you gotta unclick the relationship between all the lines, and then click on the radius. And notice that it will give you the information. What is the total length, which in this case is almost like the perimeter, the radius, the location of the center, the starting and the ending points, and so on and so forth. In many instances, the user does not know the exact value of a given dimension, so NX has a tool that allows the user to change the value of the dimensions and animate it within a given region. To do that, we're going to open a new file, Lecture 3 Part 2, and we're going to open the sketch by double clicking on it. What we would like to animate is the value of the dimension P8. To do that, we're going to go into Menu, Tools, we're going to go into Sketch Constraints, and then we're going to go into Animate Dimension. What we're going to do is we're going to change P8, and notice that at this moment it is on 43, but we would like to try it between, let's see, 35 and 45, and we're going to make it change every 2. And notice that if we do this, we applied, and notice that it gives us basically a video showing us how it will go up and down depending on the dimensions that it will have and how it will change the other parts on your feature. To stop, simply go into, there should be a menu that it says stop the animation, and simply click stop.